Number 10 and a few of the other questions next to this one have to deal with limits as x goes to infinity or x goes to negative infinity. And let's look at this first one. This is a polynomial 2x to the 7th minus 3x to the 6th plus 5. And there's not a whole lot going on with this function, but we still have to think about what's happening as x itself gets bigger and bigger as a negative number, as x goes to negative infinity. So think of it this way. If you had a really big negative number for x raised to the 7th minus 3 times another really big negative number raised to the 6th. Well, a negative number raised to an odd power, and an odd power, the negative would stay negative. So like a negative number raised to the 5th would still be a negative number. However, in the case of an even power, we'll recall that if you have a negative number raised to a power like 4, it's going to change into a positive number. So this negative infinity would be negative 2 times a really big number raised to the 7th minus 3, and then another really big number. But now it would be positive, that negative going away because of the even power. So really we got a negative 2 times a really big number is still a really big number, minus 3 times a really big number is another really big number. So that's going to be a negative infinity, and that's going to be a negative infinity. And so this whole thing is just going to keep getting smaller and smaller and smaller as it goes toward a really big negative number. And so it all still approaches negative infinity as a result. So this limit would be equal to negative infinity. And again, that's just because we're subtracting negative infinity from another negative infinity. And so it's just going to continue to get subtracted into a bigger and bigger negative number. Now here's another one with limit as x goes to infinity, but this one's a little bit different because we have a numerator and a denominator. The key trick on a one like this is to divide everything by the largest power of x, or I should say by x raised to the highest power in the denominator. So how would that look like to us? Well, in this case, x is raised to the 4th power in the denominator. So what I'm going to do is start with this limit, but then take each term in my function and divide it by x to the 4th. Okay, and by doing that we can then kind of reduce some of these powers down. Like for instance, up here on top, this will just reduce down to an x. This one would be an x to the 3rd. This one would reduce entirely, and so forth. So this is going to be equal to the limit as x approaches to infinity of 2 over x plus 4 over x cubed all over negative 3 plus 9 over x plus 10 over x to the 4th. And so what we know is whenever we have x going to infinity and we have something divided by x raised to the power, each of those are going to go to 0 as x gets extremely big. So that happens to each and every one of these things divided by x raised to a power. They're all going to turn into 0. So this limit is going to be equal to 0 plus 0 divided by negative 3 plus 0 plus 0. So really just 0 divided by a number, and so the whole thing would just be equal to 0. Okay, and here on number 14 we're doing something similar to what we did in the last one, but we have the square root involved. How I'm going to do this is I'm going to divide still both numerator and denominator by the highest, or t raised to the highest power in the denominator. And the highest power of t in the denominator is just t to the first power. So each term is going to be divided by just t. However, on top we have this whole square root business going on. And I want to divide everything there by t as well. But t first starts off sitting outside of the square root. To move it to the inside of the square root, what I'm going to do is take t and use the fact that t is equal to the square root of t squared. So by moving t to the inside of the square root, it becomes t to the second power. And so what that looks like in this case is I'll make it into the square root 64t squared divided by t squared minus 512 divided by t squared divided by t over t minus 8 over t. Simplifications will now happen because we can simplify some of these factors of t. So we're going to have the limit as t approaches infinity of the square root 64 minus 512 divided by t squared all over 1 minus 8 over t. And so remember how each of these things, when divided by t raised to a power, are going to go to 0 as t, or the variable, goes off to infinity. So this is going to be all equal to the square root 64 minus 0 divided by 1 minus 0, or just the square root of 64 divided by 1, which tells us the whole limit is equal to 8.